Okay, the next thing we're going to talk about is SOH and the law of sines, law of cosines. These really go together. So first of all, you've got to ask yourself, do I have a right triangle? If you have a right triangle, you're going to want to go right to SOH, okay? And so we know SOH. You never go from the right angle. You always go from one of these side angles. So if this is like 21 degrees and I have an X here and I have a 15 here, you're going to come from this angle. Straight across from that angle is the opposite side. Straight across from the 90-degree angle is the hypotenuse. And so I know that my last side must be the adjacent. But since we only have an X on the opposite and we have a hypotenuse, opposite and hypotenuse, if I wanted to do this problem, would be a sine problem. So to set up this equation, I would say the sine of 21 is equal to X over 15. Now, I need to get the 15 out of the denominator, so X is alone. This is X divided by 15. To get rid of divide by 15, I'll just multiply by 15. From here, it's a calculator problem. Make sure, though, that your calculator, the mode is in degrees. If it's in radians, you'll get the wrong answer. 15 sine of 21 is approximately 5.38. Whoops. Okay, there's a couple other things you're going to want to be aware of. Let's say that I gave you two side lengths, and it is a right triangle. And I gave you that this is 25 and that this is 8. And I want to know what the value of X is. Okay, I've still got a sine. There's the opposite. This is the hypotenuse. So the sine of X is equal to 8 over 25. So you need to know how to solve for the sine, or X, when it's inside a sine. And to do that, you're going to take the inverse sine, sometimes called the arc sine. It's this little sine with a -1. I'm going to take that on both sides, and it cancels the sine out. So now all I have is X equals the inverse sine of 8 over 25. And I'm actually going to plug that into my calculator by just using the second and then the sine button, and it will show that -1 up there. Once again, make sure your mode is in degrees, and we would get X is approximately 18.7 degrees. So you can work backwards for the degrees there. That's also going to come really in handy on the law of sines and the law of cosines. Okay, so if it's a right triangle, we do SOH. The law of sines and the law of cosines if it's not a right triangle. Okay, so that's when you'll employ these two. Couple things I like to look at for the law of sines. If this is my triangle, and let's say they gave me X and 24 and 8 and 12. If I can draw an X, so here's one, across from it is 1, and here's one, across from it is 1. If I can draw an X and have only one unknown, that's when you want to use your law of sines. Remember, the law of sines is the sine of A over A equals the sine of B over B. In this case, it would be the sine of X over 12 equals the sine of 24 over 8. Cross multiply, 12 sine 24 equals 8 sine of X. We're going to divide by 8. And notice again, we just hit this point that we hit on our last one. How do I get rid of the sine so that I can solve for X? It's going to be the inverse sine. So the inverse sine and the sine cancel out, and X is equal to the inverse sine of that. I'll have to plug that in my calculator to get the right answer here. You only have to do that if the sine doesn't go away. If I'm solving for an angle is when you have to take the inverse sine. If I'm solving for a side length, that won't be a problem for you. For example, if I had something like 28 57, I don't know what these side lengths would be, 5 and 12. No, oops, 5 and x, sorry. When I set this one up, I'll have the sine of 28 over 5 is equal to the sine of 57 over x. I cross multiply 5 sine 57 equals x sine of 28. When I divide, this time to get x alone, all I need to do is divide by the sine of 28. And that goes right into my calculator without actually needing to use any type of arc sine or inverse sine. So you're only going to use that inverse sine when you're solving for an angle. Okay, that's the law of sines. Now let's take a look at the law of cosines. The law of cosines is helpful when you have a setup like this, where you could draw an angle straight across, and you're going to have one unknown. Say that this was unknown, and that's what I want to find. And notice if I try to draw my second x, I have two unknowns here. I can only have one unknown in an equation, so I can't do let my x for the law of sines. So this tells me, okay, this is a perfect example for the law of cosines. You find your angle, and the side straight across from that is what you start with. So this would be 12 squared equals. From there, you're going to take these side lengths, the adjacent to the angle. Doesn't matter which one you write first. 8 squared plus x squared minus 2, 8 times x, the cosine of 40. That would be how you set that one up. So remember, the formula is going to be a squared equals b squared plus c squared minus 2 bc times by the cosine of capital A. The angle A is across from the side length. So I start right there with the side length across. The other two sides are your B and C. It doesn't matter which one is which. And then the angle, capital A, represents that cosine. So that's how I would fill that in.